So in the backward counter component, we got the same logic as in the forward counter, but we are deducting here instead of adding. Nonetheless, we can use our custom hook here. We just need to do something which we often do with functions that we write. We make them reusable and configurable, you could say, by accepting arguments, parameters. Just as our components receive props, and just as any function in JavaScript or programming in general can accept parameters, custom hooks, since they are just functions, can also accept parameters. And for example, the built-in useState hook also accepts a parameter where we set the initial state. The built-in useEffect hook even accepts two parameters where we have our effect function as a first argument and our dependencies array as a second argument. So that is something which we do already implicitly and which we can now also do for our custom hook. So which parameter could we accept here? Well, in the end, we want some indicator that controls how the counter should be incremented. We could accept this entire updating function here to make this really flexible. So here we could have our counter update function as a parameter, and then in our custom hook, just execute counter update function like this, and expect that the argument we get here is then a function that can be executed, which gets the previous counter and accepts the new counter. Or we don't make our custom hook that flexible, but instead we accept some flag, some Boolean flag here, which controls whether that should be a plus or a minus. So we could, for example, accept a forwards parameter, the name is up to you, which is true if we want to add and false if we want to subtract. And we could even set a default value so that this parameter is optional. And then here inside of setInterval, we just check if forwards, if that is true, then we update setCounter like this. Else, if it's not true, we update setCounter by, well, basically just having the opposite logic of deducting. And that's the approach I will use here, but you could also accept the entire function. Either way, we now have a new dependency here in this effect in our custom hook. Because the parameter, which I'm using in here, that is a dependency. It's not defined inside of the effect function. It's not defined outside of our custom hook. Instead, it is a value that we get as a parameter here, and we have to add it as a dependency therefore. So we should add forwards as a dependency, so that this effect will rerun whenever this dependency changes. Of course, depending on the code we write in our components, where we use the custom hook later, this might never change. It might always be true or false and not changed for one and the same component. But that's fine. If it never changes, this simply never runs again. We still have to add it as a dependency to follow all best practices and to ensure that if we would have a component where useCounter is used with different values for the argument, this effect would rerun if the argument changes. And that makes a lot of sense, by the way, because if we had a component where the counter can switch between forwards and backwards, we of course would want to restart the counter with the new logic if the value changed. But that's just some side theory here. For the moment, it doesn't matter too much. We can just go to the backward counter and import useCounter there as well, by going to the hooks folder and importing it. And then in there, in the backward counter, we call useCounter and we pass false as our argument here for our forwards parameter, because here we don't want to go forwards, we want to go backwards. We didn't need an argument in the forward counter. There we can call it like this because we got a default value in the custom hook. But if we want a different value than that default value, we have to pass it. Well, and with that, we can again extract our counter by using that return value, and then get rid of all that other logic in the backward counter component like this. And if we now save that, and we reload our application, we still have both counters working, but now with our custom hook. And of course, this was a made-up example here, and of course, besides the example on its own not being too realistic, you could definitely also find more ways of reusing logic here and working with one component instead of two counter components. But this was just there to introduce you to custom hooks. Now let's move on to a more realistic scenario where custom hooks can really shine. So here's a more realistic project. Attached you find this project where, after you downloaded it, you need to add in your Firebase links, and therefore, to understand what's going on here, you should make sure that you did not skip the HTTP course section, the section where I talk about connecting React apps to a backend. There I show how to set up Firebase as a dummy backend, and I show how sending HTTP requests works, which is of course something you need a lot in any kind of application you're building basically. So in this application here, we are sending requests, and if you want to follow along on your system, you should therefore make sure that you have a Firebase account. You can get started for free, as shown in this HTTP course section, and that there you are using the real-time database, and you got your rules configured like this. Set both read and write to true, or use the default test mode configuration, and then use this URL, which you find under data, and use that URL here instead of my URL. Keep the /tasks.json part though, you will need that. So that's what you should do to follow along. But what's this application doing? Once you updated the code and you installed all dependencies with npm install and you started the project with npm start, this is what you'll see on the screen. It's a simple tasks application, a very simple one actually, where initially the tasks are loaded. And if we have no tasks, we of course have to add some tasks first. For example, learn all about hooks. And you simply click add task, and now this is sent to Firebase. It's also displayed down there. And if you reload the application, it's loaded and displayed. And it's stored here on Firebase. Now I am only using what you learned in the HTTP course section, and this all works by sending a HTTP request with the fetch API, by handling errors and a loading state, by transforming the data when it arrives, and by then displaying the data. And we got various involved components, but most importantly, we got the app.js component where we are fetching tasks with this fetch task function, which is either executed because the component loaded due to use effect, or because inside of this tasks component a button was clicked, a button which is shown if we had an error, which allows us to try again. So that's when this fetch task function is triggered in the app component. And besides that, in the new task component, we got the enter task handler function where we also send a request, but here we are sending a post request with some data attached to store task data on Firebase. And this function is triggered whenever this task form is submitted in the end, which happens when this button is clicked and we verified the entered value. Now, feel free to pause the video and dig a bit deeper into the code, but that is what's going on here. And if you followed along in the HTTP course section, which you should have, then this is all basically just something you already saw. Now, I did create this basic yet more realistic example because here we also got another chance of adding at least one custom hook. And do you see where we could utilize a custom hook. Well, we got two similar kind of operations in two different parts of this application. And that would be here in the new task component when we send a request to store data, and in the app component when we send a request to get data. Now, regarding the details, the code is different. When we get the tasks, we configure the request like this. We send a GET request without a body and without headers. And we have some transformation logic, which we apply to the response. Whereas in the new task case, we send a POST request and we do add data, and we have a different transformation logic for the response. But even though these details are different, there are a lot of parts where the code is pretty much the same. For example, in both components, we are managing a loading and an error state, and we are setting the loading and error states in the same way. We are also having the same error handling logic here, and so on. So there are parts which are quite similar. And because that's the case, because we have some code duplication, some code reusage here, because of that, we might want to consider outsourcing this logic into a separate function. But since the logic, or at least parts of the logic, which is being reused, contains the usage of other React hooks and the usage of state, since that's the case, a regular function won't do the trick, because there we're not allowed to use React hooks. That's why here we have a great opportunity for building a custom hook where we outsource the HTTP logic and then still in the end can reuse that stateful logic for the loading and error state. And that's therefore what we're going to do now. We're now going to apply our custom hook knowledge to build another custom hook, but this time a custom hook which in the end encapsulates this HTTP logic. Definitely feel free to try this on your own first. It'll definitely be challenging, and there also will not just be one single way of doing this. Nonetheless, try it on your own first. In the next lecture, we're going to implement it together.